Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and in today's video we got another little hayman job. I went over to my neighbor friend house yesterday to just to visit, and as I pulled up in the yard and stopped, he come out. I saw he had something in his hand. He said, "I was just fixing to check with you to see if you could do a little job for me." What he's got, he's putting together an air compressor. It was an air compressor I used to have. Probably I bought that air compressor. I'm thinking about 20 years ago. It's a tall, I guess 60, 70 gallon tank, and sometime back, 5 or 6 years ago, it quit on me. And I had it buried back in a corner of the tin barn and didn't really try to get to it. I just assumed the compressor had gone bad in it. So I purchased another compressor and had it in place. And then I started cleaning up that area of the shop and got that compressor out and looked at it. And it turns out it wasn't the compressor itself, it was the motor that had gone bad. Probably the most inexpensive part of the whole thing. But make a long story short, I finally pawned it off on him in kind of a shop clean out. He carried all the pieces to his house and was going to try to rebuild the motor, but as it turns out, the motor shaft itself was actually twisted, wrung in two, inside the motor. It wasn't just a matter of bearings. So he tried a little small half horsepower motor, I think, and of course it wouldn't turn. It didn't have the torque to build up the pressure on the compressor. He wound up buying another 2-horse motor. I think it's 110 volt. Probably should have got a 220, but it's running, working good, but it only get up to about 80 pounds of pressure before it stalls the motor out. That's why I say probably should have got a 220 motor with a little higher amperage. But what he wants to try is a smaller pulley on the motor to get the motor spinning more RPM per revolution of the compressor. This is the pulley, the motor pulley. It's outside diameter 2.8 inches. That's probably a metric 70 millimeter. He wanted me to turn this down to this diameter and then recut these belt grooves in it. We talked about that for a minute. He said, you know, of course I told him that I have to grind a piece of high-speed steel to match this. But then we got to discussing it, and we decided we would leave this pulley intact and start with a fresh piece of metal. And we looked through his scrap bin and found a nice piece of round stock, a little bit bigger than this, that I could turn down. But then I got back over here to the shop. Well, actually I looked online and I found the pulley he needed, the size, the diameter, everything was right about it, including shaft size, except for it only had 5 grooves, pulley grooves, instead of the 6. And it was made out of aluminum. So that got me thinking, why not take a piece of aluminum myself and make it. This small diameter on this was 1.6. This is 1.5. So that's close enough, I think, to make the pulley that he needs. But several things we need to do, several things we need to know before we can duplicate these grooves. I'm going to get set up in the lathe, get this set up in the lathe, and we'll look at the various things we need to determine about this before we start making our new one. All right, I got you an overhead view of the existing pulley. The first thing we needed to do was try to determine the angle of that groove. This is something I did off camera in a very unscientific way. First thing I did was take something like just one of my regular inserts, which is 60 degree, 120 included. That's not right. Just trying to find something that was close. This one looked fairly close, just wasn't quite there. Tried a regular 60 degree threading tool. That didn't quite match either. So I took a piece of high-speed steel and went over to the grinder. I figured this was probably some nominal value, but didn't know how. I didn't know how to measure it. Still don't know how to measure it. But what I did was carry a piece of high-speed steel over to the grinder and just kept grinding until I was able to find a match. I then measured that, and it turns out it's 45 degree included angle, 22.5 degrees each side. So if there's a more scientific way, if you know of a more scientific way to measure the angle of a cut like this, of a groove, please drop me a comment below and let me know. I'd love to know if there is a scientific way, or if there's maybe something like a thread gauge, but only it be an angle gauge. Okay, the next thing I wanted to determine was the distance between each groove. So I'll put that in there and zero out the z-axis. Come back over to the next one, find that bottom, and I'm coming out anywhere from 88 to like 92, 93, and so forth. So I think the best way to find that is to come over here and very carefully bottom out my tool in the first groove. Zero out the DRO, and then come to the most inside one, and that is 460. Now there are 6 ribs on here, so including 0 as the first one, if I divide that 460 by 5, the number of grooves in between the 6 ribs, I come up with a value of 92. So I'm going to say that's the spacing between the ribs is 92 thousandths. Next thing we need to know is the depth of the groove. So if we come out here and just touch off, I'll zero out the x-axis, come to the center here, touching on both sides and just barely touching the bottom. And I'm assuming all these are probably going to be nominal values. And that looks like about 152, 153. So I'm going to say the depth is 150 thousandths. Let me make a note of that. Now, one other thing we probably will want to know is the distance in for the first groove. So if I zero out there, Then come to that first groove. That's 140 thousandths. Make a note of that. So I think we're ready now to maybe start putting some grooves in this piece. This piece is a little bit long, but what I'm going to do is go ahead and get the grooves in it. Then we'll turn it around and part it off to length. I've got a mark there pretty close to what the length should be. But I think I want as much holding as possible to while I'm cutting these grooves. I'm going to set that pretty close to where the end of it is. All right, as long as I got that sticking out at least to the length of this or more, then I should have plenty of room to get in here. So the first thing we want to do is get the length from the distance from the end. This is the least critical of all the measurements, but I'll zero out the X there, come into 140 thousandths. Oops, I zeroed out the wrong axis. All right, there's the 140 thousandths. So I'm going to re-zero there. And give me just a moment to do just a little bit of math. Now, first groove is going to be at 0, 0, 0. Second groove, 0, 9, 2. Add 9, 2 to that. 1, 8, 4. 2, 7, 6. 3, 6, 8. And 4, 6, 0. I realize I could use the incremental function of the DRO, but I think this is probably simpler right here. All right, let's touch off. Zero out the X. Now we're going to come in, we're just going to plunge in with this soft aluminum, 150 thousandths. All right, now we're going to move in 92 thousandths. And plunge in another 150 thousandths. Go in another 190 or another 92 thousandths. We should put our DRO on 184. And repeat the process. Set to 276. Three, 6, 8. And the final 460. All right, now let's come back out here and put a little chamfer on that one. And that should have our belt grooves cut. Micrometer says that's right on the money. All right, now we need the bore on this piece. Needs to be 5/8 of an inch. All right, I'm going to step drill this with a 13/64 and then go to the 5/8. Alright, we're going to slow the RPM down a little bit. About 450. Alright, let's see just how warm that piece is. Yep, she's pretty warm. I'm going to cool this piece off just a little bit and then come back to the lathe to part it off. Okay, since we still got a good shoulder over here and at the end, I'm not concerned about crushing these threads, so I went ahead and turned it around in the chuck in that direction. Now let's part it off. And I believe I'm going to pull the tailstock up here. Even though this is the waste piece that'll be on this end, it might have a use another day, so I'm going to keep that from falling down in the drink. Alright, I think we're ready to go over to the mill now and put our grub screw in. Got our workpiece in the mill vise now, got it centered up on the y-axis and a 1/4 inch in on the x-axis. And we're going to tap this, drill and tap it for 1/4 20. Alright, I think we're ready now to go over to the hydraulic press and broach keyway. Alright, I got the 5/8 bushing, broaching bushing, and we want to line that up with that hole for the grub screw, and then a 5/16 broach. And again, I want to try to get that in line. Alright, we'll set that up. Put a little lube on it. Remember, the tin barn's got a wood floor in it, so apologize for any camera shake. Alright, before that goes all the way through, down here on the floor, I've got an old hospital basin with a watered up sheet in it. So when that broach falls through, it won't be hitting on anything hard. You may be able to see in this in this broach the chips that it's taken out. The way a broach works, the width of course is set by the broach pattern itself, but each tooth on here is about 3/1000ths longer than the tooth before it until you get to these last three. Might be the last four on this. No, 1, 2, 3, 4. 3 teeth and then the housing. They are all the same size. So that broached part of the way. Next, we're going to use some little bushings. I'm going to go ahead and with the wider bushing to begin with, since we're broaching in aluminum. we'll set that behind the broach, that shim, and get it started again. Alright, at this point I think we're ready to measure the depth, and there are charts online, and if you got a machinery's handbook, it will tell you the measurements for what you need to know is the bore size and the key size. Okay, everything shows that with a bore this size for the 3/16 keyway, I should be looking about 525 to 530 thousandths. 527. Actually, it came out to 0.528, 527. I think that's just right. What you're wanting to be sure of is no more than half of the keyway is protruding into the bore. All right, let's go back to the workbench right quick. Okay, just a quick little recap. This was the pulley on the motor. My friend was trying to use on the motor to pull the compressor. What he was running into was a situation where he was getting a motor overload at about 80 psi on the tank. So what he wanted to do was go to a smaller diameter pulley, meaning he gets more RPMs on the motor per revolution of the pulley on the compressor, which should give him a little more torque. Obviously, it's going to take longer for the compressor to come up to pressure, but it should be able to get at least this 100-pound tank pressure, hoping for maybe 120-pound tank pressure without overheating the motor. What we did was determine the angle, and again, if there's such a thing as an angle gauge or similar to what you would have for a thread pitch gauge that you're aware of, drop me a comment below, because I'm sure there's a better way of determining angles like this other than trial and error. But we found that that was a 45-degree included angle. We got our spacing between each of the grooves. On the lathe, we turned those out. Then we went to the mill, drilled and tapped for a 1/4-20 grub screw, and then we broached out a keyway. Of course, on the lathe, we bored it out to the 5/8 inch as well. Hope you got a little something out of this. I'm not sure whether I'll go see my friend first or he'll come over here. I've got some work I need to do on the outside of the tin barn today, so I'm not sure that I'll get over there. But in any case, I'll let you know either later in this video if I find out before I publish it, or in a later video how this works out. Okay, it's the next morning now. I called my friend yesterday afternoon and told him his pulley was ready. I left him a voicemail and told him it was ready, and that I was going to be kind of tied up around on the tractor here in the yard for the rest of the day, but he was welcome to come by and pick it up if he wanted it, wanted it today. About 10 minutes later, he pulled up in the yard and ready to get it. So I gave it to him. He looked it over, said it looked like exactly what he needed. Later that afternoon, I got a text message from him that said it was exactly what he needed. It worked fine. I replied back and asked him if he was able to get the additional tank pressure he was looking for, and he said he was. He didn't tell me how much, but I'm assuming he was able to get in excess of 100 psi on the tank. He sent me this picture of it installed and the compressor running. I'm glad it worked out for him. It was another one of those enjoyable hayman jobs. So you guys take care, and I'll see you on the next video.